Hi folks, so in the last video I walked through the first page or two, page and a half of these notes. So if you haven't gotten those, go back to that video and take a look. So in this video we're just going to walk through a number of examples to try and keep some of our derivative rules straight. And also we'll be working through rewriting some of these functions so that they're easier to take the derivative of. So you and I have never seen a problem like this where I'm taking the derivative of the natural log of e to the x. Now I know the natural log of x, but natural log of e to the x maybe I've never seen before. But I do know that the natural log of e to any power is just basically the natural log and the e can cancel out. Alright, so this is actually just going to be x. Now I could go ahead and show you why that happens. Well, natural log is log base e of e to the x, right? And we could swing that x out in front by the power property. So the power property for logarithms. So basically now I have ln or x times log base e of e, and we should be familiar with that. That'll be 1. Also, I could have left it written this way and just written 1 for that. Okay, just drop that x out front, and now I have x times 1. Okay, so now we're going to find the derivative. So dy dx equals, well, drop the power in front and then subtract by 1. So we just have 1 minus. And this is a power, not a power function, this is an exponential function. So we had a power function right here, and then now we have an exponential, so we need to do the 5 to the x ln 5. Okay? Let's do the next one. The next one, we have a natural log problem, and also we have a power function. So we're going to have to use two different rules in this one problem. So dy dx equals 3 times 1 over x. I typically would not write that. I would typically just write 3 over x. In my next problem, I need to think about the square root of x and consider it as 1/2 x to the half. So my result would be 1/2 x to the negative 1. Most people, when they get into calculus, they've memorized this one as 1 over 2 square root x. Okay? If you don't have that memorized quite yet, it would have been fine if you were to write negative 1/2 x to the negative 1/2. But again, you probably want to memorize this one. This next example has a star on it. I'm not sure why, but we'll try to do it together. So we have y equals e to all of this. Now I don't know e to all this, but I do know that if I have e's like this and there's a plus sign there, then that's the same as multiplying a common base. So I'm going to rewrite this as e to the ln x times e to the 5 minus 1 over x. Alright, I like that because e to the ln x is just x. So I'm going to rewrite this as x e to the 5th. Actually, let's put the e to the 5th in the front because it's just a number. It's not a variable at all. Okay? And I don't want you to write that it's 5e to the 4th because e is not a variable. It's a number. So y equals that, and then minus. Now, okay, let's consider what we have. We have a power function. And some of you might jump to conclusions and actually say that the derivative of that is natural log, but that is untrue. This is a power function that you guys should be super familiar with. You've done this derivative already. It's just now that you're introduced with new content, you want to think that it's ln x, but that's not it. Okay, so let's do this. We're going to drop the 1 and subtract the 1, so subtract 1 from it. So that's just going to be e to the 5th. Okay, the x disappears. This, maybe I can use a different color. this is x to the negative 1, right? So you can just bring the negative 1 out front and write it as plus. And then you could write x to the negative 2. Okay? And a lot of students end up, they just do this. They would say e to the 5th plus 1 over x squared because they do a little bit in their heads. So basically when you subtract 1 from the exponent, it's like adding in the denominator. It's like adding 1 power in the denominator. And also this sign is going to change every time you do one of these. And let me see, and sometimes if it's like 1 over x squared, you have to you'll have a different number on top, but just 1 in this case. So I feel like I'm rambling about that problem, but you know, retry these problems as you need to. So here we go. We're going to find the derivative of this, and this looks like an exponential. This looks like a log. All right, and then this is a power. So we have 3 different rules on this one problem. We've done this before. So I'm going to drop the 2 out front by using the power property for logs. The power property for logs, though, is not taking the derivative. The power property for logs is just rewriting the power in front. Okay? So I have not yet taken the derivative. So I'm going to grab a different color to actually show you the derivative. Well, dy dx, well, the derivative of e to the x is e to the x. The derivative of ln x, remember, is 1 over x. So I can just write this as 2 times 1 over x. But 2 times 1 over x, I can write as 2 over x. And this time I'm going to use the power function. Power function tells me that 3 times 6 is 18. Subtract 1, so I get minus 18x squared for that last term in my derivative expression. All right, I know that this is a lot, guys. I know that these are challenging examples. Stick with it. Write the example over again, and you know, try. And give a lot of good effort for me. So this one says to find a derivative, but I have a trig function and a natural log function. So we're going to have to use both of those rules. But you see that we have a power out here, and you'll use the power property to drop that 12 before taking the derivative. So let's rewrite this as y equals negative cosine x plus, let's write it as 12/3 natural log x. Ooh, I like that a lot because 12/3 is just 4. All right. So that's just 4. Okay. So let's go ahead and take the derivative. I guess I will do the derivative in a maroon color instead of the red, since I had already used that one in this problem. So dy dx equals, what's the derivative of cosine? Well, the derivative of cosine from a previous lesson is negative sine, so the derivative of negative cosine is actually positive sine x. Plus, that says 4, but we're doing the derivative of natural log. The derivative of natural log is 1 over x, and 4 times 1 over x is just 4 over x. So that's your derivative. Let's find the derivative of this complicated expression. This is a power function? No, it's not. I said the wrong word. That's an exponential function. This is a log function. And this is also a power function, remember. Power function is different than, so don't just jump to conclusions, in other words, and take the derivative without closely looking at the problems and seeing what kind of problem they are. So, anyway, I'm going to think of this number as a 12 without writing it, and I'm going to go ahead and take the derivative. Taking the derivative will be 10 to the x ln 10, based on our exponential rule. When I take the derivative of this, remember the 3 drops out front, but that's not actually the derivative rule, that's just doing a power thing, okay? So this is going to be, I hate that I skipped that step. You know what? I'm just going to have to do that step. So, I'm going to move that text down a little bit, maybe change the pen color to a color that will represent us doing the derivative. Okay, excuse me. Alright, so what we're going to do then is just rewrite this. Y equals 10 to the x minus 12 ln x, and you might rewrite this one as 6x to the negative 1, and that last part there becomes optional as you get more and more comfortable doing these. I know students that have done that the entire year, and then I know students who jump to the shortcut a little bit quicker than that. So anyway, what we're going to do is we have this 12 and then we have this ln x, so we're taking the derivative of ln x basically, and it'd be 12 times 1 over x, or 12 over x. Alright, and then this other part would be plus 6 over x squared. Alright, so the summary. The summary just says in some situations you may have to rewrite the function before taking its derivative. You may have to use exponent properties for exponentials, log properties for logs, and really I should add trig properties for trig, and power function properties. Well, these are talking about you should use the properties in order to rewrite the function. So maybe that's not applicable. So anyway, let's do this derivative real quick. The derivative of 1 over x is not ln x. The derivative of 1 over x is negative 1 over x squared. Alright, or negative x negative 2. Okay, I don't care which one you memorize, but you better be able to go from that one to that one quickly. All right, so the derivative of e to the x is simply e to the x. I am super happy about that one because that's just friendly. Okay, maybe I should add this one if I have a derivative of a to the x. A is any number. As a to the x ln a. You won't see this on very many exams or anything, but you'll see this on a bunch of homework assignments. You won't see this on the AP exam, I should say. I could still put it on an exam in class. Alright, and the derivative of ln x is 1 over x, assuming that x is greater than 0. Okay? Alright guys, bless y'all. I did my best to show you guys some examples on how to find derivatives, how to rewrite functions as you need them, and as you need them rewritten so that you can actually take the derivative. Some of the most challenging ones are where you have a power property for logarithms, but then you actually take the derivative using just ln x, like the derivative of ln x. So anyway, I hope you guys keep those tips in mind as you do your practice examples.